Algebra 1, an integrated approach by Larson, Cannot, and Stiff. Let's get into it. Here it says about some of the authors. Talks about the authors. Ronald E. Larson. Here's a picture of him. This is Timothy B. Cannot, another author. There's a picture of him. And here is Lee Stiff. There's an image of Lee Stiff. Here are the authors, the book, all the authors. So let's get into the contents of the book. Okay, here is the first page, chapter 1, the first chapter. Chapter 1, the lessons in this chapter include numbers and number operation, variables and algebra, exponents and powers, order of operations, equations and inequalities, verbal models and algebraic models, a problem-solving plan, exploring data tables and graph. See, connections to algebra. Let's see what this is all about over here. It says, it looks like a graph, average family in the US size. So let's read what this is about, what we're talking about in this. Because one of the goals of algebra is to recognize patterns and relationships that occur in real life. Tables can help you recognize patterns. For instance, the following table shows that between 1960 and 1990, the average family size in the United States decreased by about a tenth of a family member every 5 years. The source of this is the U.S. Bureau of Census. See, as you can see, the family size in 5 years. Once a pattern has been found, it can be used to answer questions about the real life situation. For instance, from the pattern above, you could estimate that 1995 average family size is about 1/3. The bar graph gives, no, that's not 1/3. Bar graph gives a picture of decreasing family size between 1960 and 1990. Next page. Numbers and operations. Numbers and operations. Much of what you learn now is based upon numerical skills that you already have. For instance, you already know how to add, subtract, multiply, divide numbers, and you will continue to use these skills in algebra. Different kind of numbers have different names. For example, the numbers 0, 1, 2, 3, and 4 are whole numbers, and numbers are fractions. See, what you call numbers sometimes depends on the way it is written. For example, the number can be written in 3 forms: fraction, decimal, and percentage. The decimal form of some numbers contain too many digits to write. For instance, see, the 3 dots mean that the number has more digits than are shown. You can approximate this number to different degrees of accuracy. For instance, rounded 2 decimal places, you could write it as this. This symbol right here, means approximately equal to. Here's a study tip. The numbers of decimal places that you should list when writing decimal approximation depends on the context of the problem. For instance, with a dollar amount, you probably not use more than 2 decimal places. Here's a lesson investigation. Investigating fractions and decimals. Pattern activity. The decimal form of fraction must either have finite numbers or digits, or an infinite number of digits. Decide the decimal form of each of the following fractions. If a decimal has infinite numbers of digits, must the digits occur a repeating pattern? Give examples with your answer. This next page. There are 4 basic operations that can be performed with numbers: addition, subtraction, multiplication, and division. Example 1. The 4 basic operations. Addition. The sum of 12 and 7 is 19. See? Subtraction. The difference of 15 and 8 is 7. Multiplication. The product of 3 and 6 is 18. In algebra, we usually do not use the multiplication symbol x because it can easily be confused with other x, which is used for another purpose. The division. The quotient of 24 and 6 is 4. So you can see here, you can perform each of the operations shown, example 1, in your head. We call this mental math. For more complicated problems, you may want to use a calculator. Building a basketball court. A basketball court is 46 feet wide, 84 feet long. The court has a border that's 10 feet wide. The cost of the hardwood floor is 9 per square foot. How much will it cost to put a new floor on both the court and its borders? Here's an example, an illustration. The solution: to find the cost of the floor, multiply the cost per square foot times the area in square feet. Recall that the area of a rectangle is found by multiplying length times its width. Verbal model stable equation. Cost equals total cost per square foot. Area in square feet. Cost per square foot equals 9. Area length width. Length equals 10 plus 84 plus 10 equals 104. Width 10 plus 46 plus 10 equals 66. And total cost. The total cost would be 61,776. That's it would cost them to put a new floor on the basketball court and its border.